today the topic is numerical. In the last video, we have discussed all of the theory, most of the theory part. So this is the numerical point of view, numerical part. So numerical part, this is the question. This type of question generally coming in your semester exam. And it is also last semester question. The question is design a compression helical spring to carry a load of 0.5 kN. The spring which is carry load of 0.5 kN. That load is axial load, W, value given 0.5, with a deflection of 25 mm. When load is coming, deflection is given 25 mm. The spring index taken at 8. It is a parameter given, spring index 8. And assuming the following values for the spring metal, there are various assumptions, different part. For spring, these are the assumptions. What are the assumptions? Number one, allowable shear stress value 350 Newton per mm square. This value given that material, accordingly that particular material having shear stress value which is allowable 350 Newton per meter square, Newton per mm square. Sorry. Next, modulus of rigidity. It is another parameter, just like Young's modulus of elasticity. It is another parameter, modulus of rigidity. Value is 84 kN per mm square. Next, Wahl's factor. So in the theory, in the last class, in theory, we have discussed the maximum shear stress value, that is Fs is equal to 8 Wd by pi dq into, there is a parameter we have to multiply, that is either Ks, I have discussed already this is the formula, the parameter is Ks, or the parameter in place of Ks we will use simply K. Either we will use Ks or we will use K. So formula will be 8 Wd by pi dq into K. So either we will use Ks or we will use K. It is depending upon the question. So in the question it is given assuming Wahl's factor. This K, name of the K is Wahl's factor. Wahl's. It is the name of the scientist. Wahl's factor. It is factor. And Ks is known as shear stress concentration factor. It is another factor. Shear stress concentration factor. So these two factors either or we will use in the formula. So here given assuming Wahl's factor means we will use only K instead of Ks. So in the formula we will use K. We will not use Ks. So value of K is the Wahl's factor value of K is, there is a formula 4C minus 1 divided by 4C minus 4 plus 0.615 by C. This is a formula that you have to remember, and in some of the cases this formula in the question it will be given 4C minus 1 divided by 4C minus 4 plus 0.615 by C. That C is spring index. And that C value capital D by small d. Capital D by small d. This is the formula for K. And the formula for Ks, that is shear stress concentration factor, that formula is 1 plus 1 by 2C. So that formula you have to remember. For K, this is the formula. And for Ks, this is the formula. So in the question, assuming Wahl's factor means we will use K. So just proceed how to solve this problem. So first of all, see what are the data given. What are the data given in the question? Just read it. Coil spring, carry load of 0.5 kN. It is write down given data. That is value of W is given 0.5 kN. 0.5 kN. Next, just a minute. 0.5 kN. W 0.5 kN. This is axial load. Next, deflection. This is delta. 25 mm. Spring index given as 8. That is C. Then material, another items, that is assuming max allowable shear stress given, that is Fs, allowable shear stress 350 Newton per mm square. Directly given allowable shear stress Fs, shear stress. In some of the notations, the shear stress given just like tau. Some of the notation, different books they are using tau, but we are using Fs, shear stress. In most of the cases we are using shear stress Fs. So just write down Fs is equal to 350 Newton per mm square. Then modulus of rigidity, that is G, capital G. The value is 84 kilonewton per mm square. So we will go for design. We will proceed for design. So design means all the parameters. So what are the parameter? What are the parameter? That is, first we will start to find out wear time. Depending upon load, what will be the size of the wear? The spring met by using a wear. So wear means it is having certain diameter, small d. That is small d. Not given. We have to find out. This capital D is small d. Spring index. Capital D means mean coil dia. Small d means wear dia. So depending upon W, load value 0.5 kN, very high load value. So we have to decide what will be the, decide means mathematically we have to find out what will be the value of D. Okay. So let us proceed to the numericals. C value given, capital D by small d. That C value is given 8. So start the solution. C value given, that is 8 given. So 8 is equal to capital D by small d. C is equal to D by D. So capital D value will be 8 into D. Right? So first of all we have to find out to small d, then capital D, then another parameter N, number of active coil, then actual coil, then pitch, then relay. All the parameters we have to find out. Design means everything we have to find out one by one. Right? So capital D value, mean coil dia 8 into D. Now we use the formula maximum allowable stress, that is Fs is equal to, the formula is 8WD by pi dq into K. 80WD capital D. Fs value given 350 Newton per mm square. 350 Newton per mm square is equal to 8 into W value given. So first of all, you must be sure about the unit. Load given kilonewton, but stress given Newton. So change kilonewton to Newton from the beginning. So 8W, W value given 0.5 kilonewton. Convert it into Newton, multiply with 10 to the power 3 Newton into capital D. Capital D value from the formula C is equal to D by D, so D value 8 into D. This value use here. Capital D is equal to 8 into D, small d, divided by pi into, just write down dq and K. This is Wahl's vector. Wahl's vector means this 4c minus 1 divided by 4c minus 4 plus 0.615 by c. So here find out value of K. So first you have to find out value of K. So 4c, c value 8 given. This is equal to 4 into 8 minus 1 divided by 4 into 8 minus 4 plus 0.615 divided by 8. So calculate this and you will find out value of K. So you will get a value of K. That value that value will be so after calculating this value you will get value of k, and after finding this value of k, put here into here. So see in this formula after putting the value of k, that k value is 1.18. That k value is 1.18. K value 1.18. So here use after calculating it. Easy calculation. 4 into 8 minus 1. 4 into 8 minus 4 plus. So 1 by 1 calculate 1. And it is having no unit, unitless. K is having no unit, just numericals. So here you see 350 into this formula, only one unknown, that is d. So here cancel d by dq, it will be d square, and taking d square one side, all the numerical one side, you will calculate or you will find out small d value. D cancel d square, and d square one side, everything one other side. So d square is equal to some value and d is equal to square root. So finally d value is equal to just calculate d value just a minute, 5.86 mm. 5.86 mm. So before using the values, you will be thorough about the units. Units means in the numerator and denominator, unit will be same. If you will keep it in cm, numerator, denominator will be in cm. If it is in mm, it will be in mm. So it will be better to convert it into mm, because allowable shear stress given Newton per mm square, G given Newton per mm square, right? So all the units should be changed mm, then you will find out value of d is equal to 5.86 mm, right? Then small d value find out, then find out capital D. So capital D, that is mean coil diameter, 8 into small d, that is 5.86. It is also in mm. 8 into 5.86 value capital 46.88. So this is 46.88 mm. This is capital D. Right? So measure parameter capital D and small d. Find out. Next, n, number of active coil. So go for number of active coil. That is n. So formula of n. It is a formula. No derivation. It is a formula. N is equal to GD4 by 8s dq. This is a formula. G small d to the power 4 divided by 8s dq. So these parameter already we have discussed that. G is rigidity modulus, D wear diameter, S stiffness, mean coil diameter. So put the value n. Put the value of G. G given 84 kilonewton per mm square. So convert it into Newton. It is given kilonewton per mm square. So Newton means multiply with 10 to the 3. And everything given. So find out number of n. N value is equal to n value. See, in some of the cases, the value will be exactly 6. Here it is exactly 6. The value is 6 point exactly. If you will calculate 6.008. So 6.008 means it is exactly equivalent to 6 n number of active coil. But in some of the cases, the value will be say n is equal to, in some of the cases the value may be coming n is equal to 5.63, suppose in this decimal form. Suppose n value is equal to 5.63. So this 5.63 will be assumed n is equal to approximately 6. Exactly what is the meaning of n? It is a number of active coil, 1, then 2, then 3, like this. So 5.63 means 5 coils completely, there are 5 coils and another coil having just 63%. So make it 100%. So make it 100%. So it will be 6. But in some of the cases, suppose it is coming 5.16. Suppose n value 5.16. So 5.16 means it will be assumed exactly 5. Exactly 5. So like this. This process is previously we have discussed. In some of the cases there is some handbook data. But here just common sense apply. 5.63 means exactly assume number of turn is 6. Or 5.16 means number of turn is 5. So this is number of active coil. This is exactly here n value is this and n is equal to, we are assuming or we are taking n is equal to 6. This is active coil. Then actual number of coil, that is n days. So for n days, see what is the difference between active coil and actual coil? What is the difference between active coil and actual coil? From the diagram you see, or we have already discussed, n dash value is equal to n plus 2. Why? We are considering two end coils. Those end coils are not deflected like this. Here number of coil is 1, 2, 3. But the two end coils are not deflected, not responsible. Really not deflected. Deflected means during compression, these end coils are really not deflected. Only deflected 3 number of coils. So here n value is equal to 3 and n dash value is equal to n plus 2. That means 5. 3 plus 2, 5. So total number of coil, n is active coil and actual number of coil is 5. So here our active coil is 6 and n dash is equal to 6 plus 2. Plus this. So next parameter, pitch. Find out free pitch or free length. What will be? It is up to you. So free length, that is LF. Free length and pitch, that is LF is equal to n dash d plus 1.15 delta. This is LF formula, LF n dash d plus 1.15 delta. So huge, that is n dash value 8 into wire dia, small d value 5.86 plus 1.15 into delta. So delta value deflection 25. It is given. So LF value, free length value 75.6. This is in mm. Free length. Then last parameter is pitch. So value of pitch is LF by LF. So value of LF put here and n dash value put here. So So finally pitch is equal to 70.62 divided by end value 8 minus 1. That value is 10.8 mm. So these are all about all the parameters. So generally we are using this. Why we are using this to end coils, and some of the theory we will discuss in our next video. Okay. So thank you to all for watching.